Welcome to today's Friday Math Happy Hour. Today I'm going to cover the topics from Chapter 5. I believe simple interest is from Section 5.1. Compound interest is covered in Section 5.2. Future value annuities is 5.3, and present value annuities is Section 5.4. Okay, so let's start with simple interest. Okay, simple interest. This is a formula for simple interest. There's two different formulas, but I'm going to share this one with you and what everything stands for. I believe in the book they have I, but I like to put INT instead because the I might seem like a 1 or like an L. That's why I like to use INT, stands for simple interest. Okay, so the interest is a fee paid to use someone else's money. The PV stands for present value or the principal. And the R stands for the interest rate. And the key is it's a value that always has a percent symbol. Okay, that's a key that's the interest rate. And the time is going to be in years. Okay, now there's also another formula, which is future value equals to present value plus interest. Okay, now with this formula, I'm going to come out with a formula number 2 that is used in this section. Okay, for example, the interest, right? Isn't it PV times R times T? Now here, what do they have in common on the left side, right? Don't they have in common the PV? So I'm going to factor it out. So if I factor it out from here, I'll be left with 1 plus RT. So this is the other formula. In other words, it can be derived from the simple interest formula. Okay. Okay, now, so this is my formula, and also the FV stands for the sum of the principal and interest earned, or the future value. The PV stands for present value or principal, and same as the other formula, R is the interest rate, and T is time in years. Okay, so this is what we need to know. If months are given, then time, T is equal to given, and interest rate must be in a decimal. So you're going to take away the symbol and you're going to move the decimal point 2 places to the left. So for example, 5% is equal to 0.05. Okay, now simple interest continues. So let's do an example. Example number 1. It says Martha borrowed $12,000 from her uncle to buy a used car. Her uncle charged simple interest 0.5% for 5 years. Find the total amount that Martha paid to her uncle and how much interest did Martha pay. Okay, so which formula should we use? Is it the INT equals to present value times interest times time, or the future value formula? Doesn't matter. No, it doesn't. Okay, and this example, I'm going to use both just to show you that it doesn't matter which formula you use. Okay. So for example, if we use the interest equals to present value times interest rate times time, then to find the future value, we're going to get the present value plus the interest. For example, the present value is the amount that Martha borrowed, and then we also going to include the interest. With the first formula, the one on the left, we're going to find the interest. Then to find the future value, we're going to add the present value plus the interest. Okay, so let's do it. So I tell my students to always put everything, right, the interest, the present value, the interest rate, and the time, and then from the word problem, you're going to extract the information. So for example, on this one, what are we looking for? Right, sorry that I clicked the mouse, but it says Martha borrowed $12,000 from her uncle to buy a used car. Her uncle charged simple interest at 3.5% for 5 years. It says find the total amount that Martha paid to her uncle. So in other words, we're looking for the future value, right? And also we're looking for how much interest did Martha pay. So if we're going to use this formula, so we're looking for the interest first. How much interest did Martha pay? So the present value is 12,000. My interest rate is 3.5%, right? And remember that you don't use, that you have to convert it into a decimal form, right? So we drop the symbol and we move the decimal place 2 places to the left. So that's why it's going to be 0.035. And the time, right, it's already in years, so the time is 5. So, right, so we put the formula and we're going to plug everything down. You see, so my present value is 12,000. My interest, my R is 0.035, and my T, which is time, is 5. So I will do that, plug it in, and use a calculator. So the answer is 2,100. Okay. Now, right, so this is the second part of how much interest did Martha pay, right? So this is the answer for the second part of the question. The first part, you're trying to find the total amount that Martha paid altogether to her uncle, which is the interest plus the amount borrowed, right? So then it's going to be 12,000, what you borrowed, plus the interest. So we add them up, and the answer will be 14,100. So that's how much she had to pay in the 5 years. So the total Martha paid was 14,100, and the amount of interest was 2,100. Okay, now let's go to the next slide, and we're going to do the very same problem, but we're going to use the other formula, which is the future value equals to present value, 1 plus interest times time. So in this case, right, find the total amount that Martha paid to her uncle. So we're looking for the future value, right? So again, my present value is at 12,000. My interest rate is 3.5%. Converted to a decimal will be 0.035, and my time is 5 years. So let's plug him into the formula. There's my 12,000. 1 plus 0.35 times 5. So we plug that in the calculator just the way it is, and we get 14,100. So this is my future value, right? Then to find the interest earned, so we subtract the amount borrowed, which was 12,000, from the future value, which will give us the interest. You see, students, so it doesn't matter what formula you use, right? But what matters is that you know exactly what formula to use, right? With a formula that we use, for example, for the future value, right? I mean, for this formula, we have to use the interest equals to future value minus present value. And in the other one, we have to use the future value is equal to the present value plus the interest. Again, same amount as the previous slide, which is using the other formula. Okay, now, so let's do another example. It says here, Mariana will need to pay a tuition bill of $7,500 for her daughter in 10 months. What dollar amount can she deposit today at 1.25% simple interest to have enough to pay the tuition? So let's see. So here, guys, we have to use this formula here. Why is that? Okay, because she wants this amount, right? It says here, Mariana will need to pay a tuition bill of $7,500. So this is in the future, right? This is in 10 months. So in other words, we're trying to find what dollar amount can she deposit today, right? So we're looking for the present value. So the future value, right? So she wants this amount, the 7,500, in 10 months. So that's my future value. My interest rate is 1.25%. Converted to a decimal becomes 0.0125. But the time is not in years, it's in months. So we have to put 10 divided by 12. Here's where a lot of students make mistakes. Just because they see 10, right, in months, they put 10 for time, and it's wrong because the time's supposed to be in years. So I always see this common mistake that students make, that they want to put 10 instead of 10 divided by 12. Okay, so please do not make the mistake. Now all we do, right, this is a formula, the PV equals to future value 1 plus RT. This is the formula that the book uses. And at times students have a hard time with this formula. Why? Because they don't know how to use a calculator. So I'm going to show you the way the book does it, then I'm going to show you another way, which is just using the basic formula from the beginning. Okay, so I'm going to do it both ways. So if you're calculator savvy, you should be able to do it this way or any way. But if you're not, especially students that haven't been in school in a long time, they come back to school and they struggle using the calculator. Okay, But anyway, guys, right? So on the bottom right, all we do is plug it in just the way it is. 1 plus 0.0125 times 10 divided by 12, and it's going to give us 1.0104166667. And then if we divide the 7,500 by the denominator, it's going to give us 7,422.68041. Right? And they always want you to round off to the nearest penny. So for example, the nearest penny will be always two places, two decimal places. Why? Because the 6 is where the dimes go, and the 8 is where the pennies go. So it's going to be 68 cents. Okay, now another way without clearing the calculator. If you do it this way, right, you have to be a calculator savvy in order to put it all in one shot. Or you can just find the value here in the denominator first, and then clear the calculator, and then use 7,500 divided by what we got here, which was a 1.01041667. But I'm going to show you another way that you don't leave the calculator. Okay, it's like a steady flow. Okay, and here we go. And most of the times it's with a TI-83 or a TI-84. If you didn't know, students, these calculators can be rented at your campus. Just go to the math lab and ask the instructor that you want to rent it for. They rent it for $10, and it's very, very useful because you can use it for the whole semester. And I mean, this way you don't have to purchase this because they're kind of expensive. They're about over $100. Okay, so you can rent it out. Okay, now so I'm going to show you with a TI-83 or TI-84. Okay, guys, so this is what you do. Okay, so you're going to plug everything in, right? This is my future value, right? I got it from the info on top. My R, which is my interest rate, is 0.0125. It's there. And then times 10 over 12. So I'm going to enter 1 plus 0.0125 times 10 over 12 in the calculator. Okay. If you want, you can put parentheses if you want, but you don't have to. But it's always safe to put the parentheses, right? This opens the parentheses, and the one at the end closes it. This should be the answer. Okay. Once you see this answer, you're going to click the inverse key. The inverse key is there. I mean, there's a key that says X or -1 means the inverse key. So you're going to hit this key, and then you're going to enter the value or the number on the left. Right, when you press the inverse key, you should see answer to a -1, and then enter 7,500, and that's right. You enter that, and that's your answer. You see, we get the same answer. And this way, you don't have to stop the calculator and clear it. It's one steady flow. Now, let's do another one. Example number 3. John received a $10,000 loan from his aunt to buy a car. His aunt charged him 2.5% interest. How long was the term of the loan if the interest accrued was 125? So here, it doesn't matter what formula we use. In this case, it does matter. Why is that? Because the interest accrued is a INT formula, right? This is what the INT is, interest accrued. Don't get it mixed up with interest earned and interest rate. This is the interest rate DR. So in this case, we have to use this formula because we're solving for how long, right? Which is time. So then, right? So it does matter here, guys, because this one over here doesn't have a place for the interest rate. I mean, for the interest accrued, right? There's no INT here. That's why we're forced to use the INT formula. So we put everything down, right? The INT, the PV, the R, and the T. What is given and what are we looking for? We're looking for how long, which is time, right? So then the interest accrued was 125. Okay, this was the PV, and the interest accrued was 125, right? So we have everything there. Sorry that I worked a little bit backwards here. But anyway, the key where everything goes is the PV is always the amount, right? That's a PV, present value. And the interest rate is always the one that has a percent symbol, which is a 2.5. And then the interest accrued was a 125. I always tell my students that please show me all these variables here on the left, And this way, I will count the problem. I'll give you credit if you can extract the information. And I too many points if the students have a hard time plugging to the calculator. Okay, but this is what I want to see. And every instructor is different, but I like to give credit if students understand the word problem and if they can extract the info correctly. Okay, but like I said earlier, every instructor is different. We all have different ways of trying to grade each problem for credit. Okay, now, so again, plug into the formula, right? So we're looking for T. So 10,000 times 0.025 will give us 250. Then we divide by 250, both sides, and we get 0.5, which is 0.5 years. 0.5 years is half a year. Let me go back. Hold on. So it's going to take half a year for a situation to occur, right? So again, how long was the term of the loan? If the interest rate occurred was 125, it took half a year. Half a year for John to pay. His hand back. Okay. Okay, now compound interest. This is another formula. What's the key? Because at times students ask, Mr. Isas, what formula should we use? How do we know what are the key words? Hey guys, where it says simple interest, we're going to use the two formulas that we used in the past few slides, which is something from 5.1. When it says compound interest, it's going to be something from 5.2. So compound interest and simple interest are the key words to look for. Okay. So now compound interest is a different formula. Okay, it can be two formulas. This formula, the future value equals to present value, parentheses 1 plus r divided by m, close parentheses to the power of mt, is the same formula as the one on the right here. Because if you notice, the I is equal to r divided by m, and the n is equal to mt. This formula here on the right is easier to plug in the calculator. Okay, so now, so the future value stands, the AV stands for future or maturity value. The PV stands for principal or present value. The R stands for the interest rate per period converted to decimal, as I mentioned earlier. Now this is new here. This is the M stands for the number of compounding periods per year. And the T is the same as before. T is time in years. And I is equal to R divided by M, which is the interest rate per period, right? And again, I repeat, the I replaces the R divided by M, which will be easier to put in the calculator. And the N is the N times T, which is the total number of compounded periods. Okay? Okay, now, here are key words for compounded. Okay? When you see the word yearly or annually, you're going to plug in 1 for the M. If you see or you read the words bi-yearly or semi-annually, M is equal to 2. Quarterly, M is equal to 4. Monthly, M is equal to 12. Weekly, M is equal to 52 because there's 52 weeks in a year. And daily is going to be either 360 or 365. At times, the book might be specific to use 360 if it's compounded daily. And if it doesn't say, right, to use 360, it's always 365. And also, there's another formula that's called compounded continuous. Continuous is a whole different formula, which is future value equals to present value, the E to the RT. Okay, now, so let's do an example. And again, how do we use compound interest? Compound interest is to invest a certain amount of money without depositing additional money. So say, for example, say you have something like, say you had like $1,000 or like say $2,000 they're at your house, right? And you're thinking, well, I want to put them in the bank so I can earn interest. So the $1,000 or $2,000 or whatever amount you have, just put it in the bank, right? And then you deposit extra money. So you leave it there in the bank for so many years, and then you're going to get money back for it. Okay, now an example. Example 4. You deposit $1,000 in an account at your bank that pays 6% interest compounded quarterly. How much money will be in your account after 5 years, and how much interest did you earn? Okay, so here's a scenario. There's my formula. Remember, it's easier to use the one on the right because it's easier to plug into the calculator. What are we looking for? We're looking here for two things, right? How much money will be there in the account after 5 years? So we're looking for the future value. And then after that, right, we're going to use the future value equals to present value minus the interest to find the amount of interest that you earned. So then we begin to extract the info. You deposit, right? You deposit means that you deposit this amount, the $1,000 right now. So present value is 1,000. The interest rate, right, which is a variable R, right? And like I said earlier, that's very easy to see because it's a one that has a percent symbol, so it's going to be 6%. But please don't forget to convert it to a decimal, which will be 0.06. And here's another mistake that students make: they put 6 for the interest rate, which is not correct. Okay, now if you don't know how to, if you have trouble moving it to the left two spaces, just get the original, the 6%, and divide by 100. It's going to give you the correct interest rate, and you drop the symbol. Okay, you can do it that way. Okay, now the M, right, is the amount of compounded per year. So we have to look for the keywords for compounded, and here it is, compounded quarterly, which means 4. And the amount, the amount of time is 5 years, so T is 5, right? And it's in years. So then the I will be 0.06 divided by 4, which is equal to 0.0125. And the N is equal to M times T, which is equal to 4 times 5, which is equal to 20. You see, now you can plug into the calculator, right? And it's very simple to use because this one has too many variables. So I believe the one on the right here is much user-friendly to plug in the calculator. So now how do we plug it in? We just plug it in just the way it is, exactly the way it is. So that's your answer, which is $1,346, and you round out to the nearest penny, which will be, you're going to round out to 2 places, right? So you always look to the 3rd place, and if it's 5 or more, you add 1 here. So it's going to be 86 cents. See, so that's your answer. So after 5 years, there will be $1,346.86 in the account. So how much interest did you get or did you earn? Right? So again, we use the interest earned, which is the INT equals to future value minus present value. How much money did you get at the end of 5 years, which is $1,346.86, and we subtract it from the amount that you deposit, which is 1,000. So you're going to get $346.86 in interest. Okay, now, hey students, this is what you know because when I was growing up, the interest rate that they paid was like 9% or 10% back in the 80s and 90s. And this 6% is very generous. Now, they actually pay you like 1.5% or maybe 2. The most that I've seen is 3%. Now, the banks, they don't pay as much as they used to, okay? So before you deposit or before you want to deposit something into account, make sure that you use the formulas to see how much money you will get in the future. If you think it's worth it, go for it. And if you think it's not, right? Because at times when you get a CD that you want to put some money in, there's some CDs or some accounts that you cannot take the money out. Or if you do, they might punish you, right? Or I mean something like that. So please make sure that you use these type of formula to make sure that it's worth it to put the money in the bank. Okay, now continuous compound interest. Remember that I mentioned, guys, that if it's compounded continuous, right, it's going to be a different formula. And here's my scenario. This is the same scenario as the previous problem, but the only difference is a compounded period. Okay, so again, this is a total different formula. So we're looking for the future value in 5 years. The present value is the same, 1,000. The interest rate will be 6%, which will be 0.06, and the time is 5 years, right? But it's compounded continuously. let's see what it means by continuously. Okay, so let's put in the formula, right? So we put it in just the way it is. And in this case, be real careful that it depends on the type of calculator that you're using. It's always wise to put it in parentheses. If when you put the power, right? I mean, when you put the E function, and it gives you like a little square, right? Like the exponent, you need parentheses. But if you have to put the caret, right? If the calculator gives you like a little caret like that, like an upside down arrow like this, and then it gives you the parentheses, or if it doesn't give it to you, you have to put the parentheses. If not, you're gonna get the wrong answer. So just be real careful with the calculator that you're using. I believe the ones that you borrow or rent out from the math labs at the EPCC campuses, you don't have to worry about the parentheses. If you have an older version, make sure that you put the parentheses correct. Or if you want to play it safe, multiply 0.06 times 5 and then put power of that. And that way it will eliminate mistakes. But anyway, that's the answer that we get. $1,349.86. So after 5 years, there will be $1,349.86 in the account. So how much was interest? Right, so we use the same formula as the previous slide, which is that's the amount that we got in the future in the 5 years, minus the 1,000 that you deposited. So the answer will be $349.86. I believe the higher the interest, right? I mean, the higher that is compounded, the more money that you get. Not by a lot, but it increases the interest earned. Again, the higher the compounded, the more amount they're gonna earned. Okay. So now this compound interest continues. Another example, number 6. It says, I want to be earning an annual salary of $100,000 when I retire in 15 years. I have been offered a job that guarantees an annual salary increase of 4% per year, and the starting salary is negotiable. What salary should I request in order to meet my goal? Okay, this can be like an actual scenario, right? Like a real life scenario. Say that you graduate from college, and then you're going to go into a company, right? And say you want to retire in 15 years, and you want an annual salary of $100,000 when you retire. So the job, right, offers a 4% increase in salary every year. So how much money should you ask right now in order to meet that goal? You see, this is the type of scenarios that is used in real life, right? So this is how you use math and these type of formulas. Okay, again, so we're going to use the friendly using formula for the calculator, which is the one on the right. So let's put all the variables, right? Which there's always 7: the future value, the present value, the interest rate, the compounded times, the time, the I, and the N. So here, let's extract the information. I want to be earning an annual salary, right? So this is what they want in the future, right? So it says, what salary should I request in order to meet my goal, right? So we're looking for the present value. That's what you want to find out. How much money should you ask now, right? Which is a present value. So then after you know exactly what you want or what you're missing, right? Or what you are solving for, then all the rest is very, very basic. Fill in, for example, the other money that's given, then that has to be my future value. My interest rate, like I mentioned earlier, is a number with a percent symbol, which is 4%. And don't forget to convert it to a decimal, which would be 0.04. Now here, M, right? It says annual salary, right? You don't see no more compounded, the word compounded, right? But here the keyword is annual. So M is equal to 1. The T, the time stands for 15, right? And it's already in years, so it's going to be 15 years. You see, guys, so I got all the info that I need. Now, for the I, right, we get R divided by M. And like I tell my students, if it gives you like a finite number, that's what you use. By finite, you see this gives me 0.04, which is a finite number. But if you give me something like 0.04, and then it continues right all the way to the end, it means that you have to round off. But on your My Math Lab, or the platform that you're using to do the homework, at times you might, if you run off here, you're gonna end up getting the wrong answer because they're real strict. If they want it to the nearest penny, right? Then you have to round it off to the nearest penny. If not, it's gonna give you like a wrong answer. And the end will be m times t, which is 1 times 15 is 15. So now let's plug everything in. Okay, now you see, so first, right, we plug in 1 plus 0.04 to the 50th power. That's what we get. Then we divide both sides by 1.8009435506. Right, so that's what we get. And then we divide that 100,000 by 1.80943506, and we get the present value, which is $55,426.45. Okay, now again, I'm going to show you how to use a calculator, right? That way you don't have to stop the calculator, because I believe here you have to stop it, right? You have to clear it and then put the 100,000 divided by the 1.80943506. So again, I want to show you how to use a calculator, right, in a steady flow. And here we go. Right, so we're going to start from here, right? So first, right, we're going to enter 1 plus 0.04 close parentheses to the 50th power in the calculator. So this is what you should see, right? You should see 1.8094943506. Everything in green is what you're going to be seeing, right? This is what you input, and this is what you see. Then you're going to hit the inverse key, press the inverse key, which is this key here, x to a -1. Then this is what you should see, answer to a -1. Then you're going to enter the 100,000. After you enter that, there's your answer. You see, you don't need the calculator, guys, a steady flow of the calculator. This is, I like to show this to my students, that way they don't make the mistakes. And I believe I got some real positive feedback from students that actually followed this workshop, and they use it in their math, and they told me that the way I explained it here was very, very simple to follow. And you can check your work, right? You can practice by inputting how I mentioned here on this slide, and see if you get whatever I say that you need to see. For example, here you should see the 1.80943506, and when you press the inverse key, this is what you should see, answer to a -1. Then you enter the 100,000, and this is what you see. So then there's my answer. But the book uses this formula, which I believe if you struggle with a calculator, this might be a little bit more challenging. Okay, the formula, and I believe also the platform, My Math Lab, this is what they use if you ask them for help, or if you want an example, this is what they use. Okay, but you have an option. You can follow the examples there, but I give you another option to use the inverse key to find the present value. Okay, now this is the future value of an ordinary annuity. This is something from 5.3. And now, if you notice, every section has a different formula. And if you notice, the formula on the right is much more easier, right, or more friendly for the calculator. And still, the RM is equal to my I, and the MT is equal to my N, same as before. Okay. So let's see what everything stands for. Okay, now the future value of ordinary annuities can be used to accumulate funds for some time in the future, but you must set regular deposits during that specific time. Okay, again, you're going to start, right? So here you're going to input a certain amount of money, the same amount every month or every compound period until for a specific time, like say for 5 years, 10 years, whatever you want to set. Examples. Let's say you can afford to save $1,000 every month, and you want to set up an annuity to make interest on the account. You want to deposit $1,000 at the end of every month for 20 years. How much money will you have at the end of those 20 years? Okay, this is a type of example. Another one can be something like, and this is what I tell my students in class, like a real life scenario. Okay, let's say that you are planning on sending your just born child to college when he or she turns 18. Since college tuition is constantly on the rise, you want to make sure you have enough money in 18 years for your child to attend college. Okay, now, and this is like a very, very true scenario, because if you're in school, right, you're here to get a degree and actually graduate and be making money, right? Be making like a lot of money. That's the purpose of going to school. So more than likely, if you got financial aid, right, to go to school, more likely your kids will not get financial aid because you'll be making a little bit more money, right? So more likely you might get financial aid, right, for your kids, but not that much. And to be honest, more likely they're not going to get financial aid because you overqualify. You make too much money. So this is a good plan to use to start saving money in the future. I mean, for this scenario. Okay, now the next two examples that I'm going to cover these two scenarios here, so you can know exactly how they work. Okay. Okay, now example number 7. Say you can afford to save $1,000 every month, and you want to set up an annuity to make interest on the account. An investment company offers 3% interest for the 20 years if you deposit $1,000 at the end of every month. How much money will you have in 20 years, and how much interest will you earn? Okay, now I like to use 3% because that's a maximum that I've seen in the past 3 or 4 years. This is a maximum that I've seen that an investment can offer, guys. And also, there's companies that or brokers that will tell you, you know what, you can, you'll be guaranteed this deposit, right? But most of the times that they guarantee you 100%, right? Most of the time they offer you, little interest. Why? Because there's not a risk. The more that you risk, the higher the interest that you get back. Okay, but this is a good, like I said, the highest that I've seen in the past 4 years. So let's do this scenario here. Okay, and again, you can relate it to yourself. Say that you can afford this amount, right, and still live comfortably, right? But this amount is just extra money that you can save every month. Let's see the outcome of the scenario here. Again, so this is a formula that I'm going to be using, right? So you can afford to save, right? So we're looking for, let's see, how much money will you have in 20 years? So we're looking for, right, for the future value, because this is how much money will you have in 20 years. Okay, so let's plug everything in. So the payments that you're putting in, right, are $1,000 every month. The interest rate that they offer you is, so it'll be 0.03. And let me see what set up annuity that makes interest. Let's see here. What you make, okay, every month. Here we go. Right, this is every month means 12. Okay, we're looking for the component which is every month, right? Which is 12. The time is 20. So the I will be R divided by 3, which is 0.03 divided by 12, and it gives us 0.0025. The N, right, is the M times T, which is a 12 times 20 will be 240. So what we do is plug into the formula, right, just the way it is. There's my payments per month. And there's my I, 0.025, right? So there's my formula. So all you do is plug it into the calculator, just the way it is. Right, so you start by doing that first, right? And then you multiply them out, right? The 1 plus 0.0025 to the 240th power minus 1 gives you 0.82075499953. You divide by 0.0025, and this is a result, 328.3019981. And then you multiply it by 1,000, right? Because that's how much you were depositing every month. So you're going to get $328,301.99, right? But you ended up, this goes to $2 because the 99 cents runs off to $1, which will be 302. So this is how much money you have in 20 years. Okay, now let's see how much of it was interest. Okay, so how do we do that? Okay, again, I'm going to show you the same process, right? But with one steady flow of the calculator. Right, this is what you input, minus 1. You see, that's what we get, which was here, the 0.82075499953. Then you press the division key, divide that by 0.0025. You enter, you see you get the same value as what we did here on the left. And this is without leaving the calculator, something like a steady flow. Then you press the times key and you multiply by 1,000, and this is what you get. You see the same answer. Okay, now, how much money did you invest? So how much money really came out of your pocket? Okay, so let's find out. How do we find that out? How many payments did you make, right? 240. So you multiply 240 times the 1,000, right? Because you're making payments of 1,000. So you made 240 payments, or deposit 240 payments, right? In 12 years. In 20 years. So you multiply 240 times 1,000. So you get 240,000. So that's how much money came out of your pocket, 240,000. So now, how much interest did you earn, or how much free money did you get just for depositing the $1,000 every month for 20 years? Right. So we subtract the total that you got in the future value minus 240,000, which you got $88,302 in interest. I believe that's worth it, right? Because if the money didn't affect your finance every month, then this is a good strategy to do. And at 3%, I got something that's the best in the past 4 years. So this is like a real life scenario. This is how you use formulas, guys, in math situations, how to make money, right? And how to invest money. Okay, now here's another scenario here. This is with the other example that I told you guys, okay? You are planning on sending your just born child to college when she turns 18. You want to have $250,000 in an account for tuition in 18 years. How much money must you deposit at the end of each quarter in an account that pays 5% compounded quarterly? Okay, so now we get the formula right. We put everything that's down. So again, what are we looking for? How much money must you deposit at the end of each quarter? So that means you want to have $250,000 right in the future. So we're looking for how much money, or the money that you must pay every month or every quarter. So we're looking for the payment. So then, the value, right, that you want in the future in 18 years will be the 250,000. The interest rate is 5%. The M, right? So compounded. Let me see how many deposits compounded. We see compounded quarterly. So M is equal to 4, right? Because it's quarterly here. And the time is 18. And the I is R, 0.05 divided by 4. We see it gives you something finite, which will be 0.0125. And the N is M times T, which is 4 times 18, gives us 72. You see, guys, so here's my formula. And like I said, I'm going to use, right, from now on, I'm going to show you how to do it in the calculator with one steady flow. Now, let me go back one. So you're going to input first the 1 parentheses 1 plus 0.0125 close parentheses to the 72nd power minus 1 in the calculator. So this is what you should see on your screen. 1.4459202268. Then you're gonna hit the division key, right? And then and this is what you see. On your screen, you should see the answer and the division, right? So then you're gonna enter the 0.0125. After you do that, this is what you should see on your screen. 115.6736215. Then you're gonna press on the inverse key, right? When you press on the inverse key, this is what you should see. Answer to a -1. That means this answer, the 115.6736215 to the -1 on the screen. Then you're gonna enter the 250,000. So you're gonna get 2161.25334. Right, so this is the amount of money that you must deposit every quarter. You have to deposit $2,161.25. Okay. Okay, now extra information. So how much money did you put into the account? So if you pay this amount, right, which is $2,161.25, and you made 72 payments, right? So we're gonna find out how much money you paid in the account, and how much money was free money or the interest that you earned. So we multiply that out, right? So it's gonna be 155,610. So that came out of your pocket. And wow, right? So, but you got 250,000. So that means that you got almost 100,000 extra just by making this investment. 94,390. I believe this is a good investment, guys. And maybe if you guys plan on sending your kids to college and actually paying for them, which you should, I believe this is a good formula to use. Okay. So 94,390 came from the earned interest. I believe I have one more formula to cover, which is the present value of an honorary annuity. This is something for 5.4. Okay. So most common use of present value ordinary annuities are for purchasing an expensive item, such as a vehicle or a house at the present time and making equal payments, including interest for a certain amount of time and years. Examples. I like to use these three examples because this is for most, this will probably be your largest investments that you make. A new car, right? You want to get a new car. And also you want to get an idea on the process of buying a house, right? Because when you're in school, I mean, most of you, or most of us, right, are live with our parents. And the most important items that we want, right, is a car. That's the first one that we want, a car, brand new car. And the next one is after we graduate and all that, right, we want to purchase our own house. So let me show you guys two situations, right? I'm using these two examples. But here, you want to get an idea on the process of purchasing a house. Okay, this is what you got to know, okay? Key factors of purchasing an expensive item and payments. Must have a job. No job, the bank is not going to lend you a penny with no job. So you must have a job. Also must have very good credit. There's ways to actually improve your credit. Okay, but you must have very good credit. The higher your score, the higher your credit score, the lower the interest rate you will get. But if you have real bad credit, more likely your interest rate is going to be higher. But to purchase a house is real hard to purchase a house if you have bad credit. Okay, they want you to fix your credit first. Now, also to buy an expensive item, right? Especially a house, you have to get pre-qualified for the maximum amount of a loan. So, for example, when you're buying a house, you want to get qualified to you see with what your income or I mean your spouse income to see what's the maximum amount. Because if you go looking for houses, right, and you're not pre-qualified, you might be looking at houses that are more expensive than what you can afford. So, and then if you're doing that, right, then when you see something that you can afford, something much lower, then all those houses will not seem right because you were shown houses that were more expensive than what you can afford. That's why the best thing to do is to get pre-qualified for the maximum amount, and then the agent will take you on houses that you want to see, right, that fit your budget. Okay. Now, let's do those two examples now. Example number 9. Say you buy a new car that costs $26,750. What are the monthly payments if the interest rate is 4.2% and the loan is for 5 years? How much interest did you pay? Okay, so let's see that scenario there. So again, right, now we use the present value. The present value is how much money that you borrowed from the bank right now. And the payments will be, most of the times when it's a house or a vehicle, it's monthly payments. So the M will always be 12. So then, okay, let's see the scenario. So let's see here. So what are the monthly payments, right? So we're looking for the payment. So the money, so the present value that you need right now, right, from the bank is that you want to borrow $26,750. The interest rate is 4.2%, right? But you convert it to a decimal, which will be 0.042. And the M, right? The M are monthly. So like I said earlier, the compounded will always be 12 for purchasing a vehicle or purchasing a house. So it's 12. The time is 5 years. So again, the I, we're going to use the formula will be R divided by M, 0.042 divided by 12, which gives us 0.0035. And the N is equal to M times T, which will give us 12 times 5 will be 60. Let's plug everything in. Okay. And again, we're going to use the inverse key, right? Because we're looking for the payment, right? If we were looking for the, say the payment was given, right? And we're looking for the present value, I would just plug it in just how it is in the calculator. But in this case, a key thing is that we're going to have to use the inverse. Okay. So again, let's input the numerator on the calculator just the way it is. This is what you should see. 0.18911850031. You're going to press the division key, and then that's what you see on the screen. And then you enter the 0.035, and this is what you see. So you're going to see 54.03385.802 on the screen, and then you hit the inverse key, right? And that's what you should see on the screen, and then you enter the 26,750, and that's what you should see. So your monthly payments are going to be $495.06. Okay, now how much money did you end up paying? The price, right, of the car was $26,000, but did you really pay that, or did you pay more, or did you pay less? So you're going to pay more, okay, because you're paying that 4.2% interest. So how much? So let's get the payment right. There were 60 payments. So you multiply by 495.06. You get $29,703.60. You see, so it's not what the car was worth. You paid about about $3,000 more. How much more? To be exact, right? We subtract what we got on all the payments, right? The total from the 60 payments at $495.06 minus the original price. So you paid close to $3,000 in interest, which is not bad, right? For 5 years, which was $2,953.60. Okay, now could you have paid less? Sure, you could have. If you could afford to give like an extra payment, like extra money every month, then your loan would have not been 5 years. It would have been a lot less, and also your interest that you paid would have been also a lot less. As when my wife purchased a house before we got married, we used mathematics to pay it off in 10 years. You see, because we always paid extra on the principal. So we got to pay it off in 10 years. And the loan was for a 30-year loan. You see, guys, so you can use math to your benefit. Don't settle for the minimum payment, right? So you always give more, but make sure that you tell them that it's going to be for the principal, which means it goes straight to the principal. And this way you can pay it off in least amount of years. And the total interest that you'll be paying will be a lot less. Okay, and that's an example that I'm going to show you, example number 10. Okay, but anyway, you end up paying $2,153.60 in interest. Okay, now I believe this is my last example. So say you want to purchase a house for $325,000 with your fixed rate 9%. What are your monthly payments and how much interest did you end up paying? Okay, so let's see this scenario here. So again, we're looking for the monthly payments. So the present value that you want to borrow from the bank or that you qualify was $325,000. Interest rate is 3.9%, which will be 0.039. And again, the M will always be 12. The T is going to be 30 years. So the I will be R divided by N, 0.039, 12. And the N will be, which will give us 0.00325. And the M will be 12 times 30, right? The M times the T, right? Which is the M is 12 and the T is 30. So it's going to be 360. So let's plug them in. And let's use the inverse key because we're looking for payment. So the same process as I showed you in the previous slide, right? We're going to enter the numerator here in the calculator just the way it is. And then we should see 0.6890436901. Then we press the division key. So this is what you see. And then we enter the denominator, which was 0.00325. So this is what you should see. So this whole right side is equal to 212.0134431. That's what you should see on your screen. Now we hit the inverse key, right? So this is what you should see on the screen, and then you enter the 325,000. So this is what you see. So your payments will be $1,532.92. Those are your payments. Okay, now, hey guys, but here, guys, please do not be deceived by what you're paying here. Also, not included is a property taxes, which it depends on what side of town do you live. I believe if you live in the lower valley or the northeast, your taxes, if you live on the Isleta district, your taxes will be lower. If you live on the east side, far east, or the west side, your taxes will be much higher. So it depends where you live. And also the same kind of house on different areas will not be the same price. They'll be different. So for the scenario, the monthly payments will be more than this because the taxes of the house are not included. And also there's also a PMI charge, but roughly your payments will be a little bit more than this, guys. But this is just including just the payments with not the insurance also nor the taxes. Okay, just the payments. So this will be like the minimum. Okay, now, so how much money did you end up paying? So what we made 360 payments of $1,532.92, right, every month. So we're going to multiply those together. So we got $551,851.20. So that's how much you end up paying, right? Isn't it amazing, guys, that you end up paying like 225,000 more? You see, so you end up paying $226,851.20. So then, how much was interest? How much extra money did you pay? How much interest, right? Because the house was $325. So you paid $226 in interest. Okay, this is how much interest you paid, which is a lot of money. How can you avoid all this interest? Again, like I mentioned in the previous slide, you pay more money. If you have extra money, put it into the house, into the principal. That's what we were able to pay the house in 10 years, the one that we got here in Northeast. Okay, guys, at the Northeast area. So anyway, guys, you can use these type of formulas to help you actually on your finances, how to pay this amount of interest and how to earn more interest. I hope that you enjoy this presentation. This presentation, guys, is always my favorite one because here is where students really begin to ask questions because we all want a nice car and a nice house. So this is a topic or a chapter that actually gets the students' interest. And like I said, I was very happy to present this workshop, and hopefully you can use it. You can apply it to your daily lives. Thank you.
Thank you, Mr. Zassi. Is there any questions for Mr. Zassi? All right. Well, if not, I'd like to thank you, Mr. Zassi, and thank you, Antonio. He wishes you a good day, Mr. Zassi.
Well, thank you, my friend. Thank you. Thank you.
Thank you for presenting for us this Friday afternoon, and thank you for joining us. So before I let you go, I'd like to invite you to next week's sessions. For Math 1314 and Math 1324, we'll be going over the exam to review. So if you're got that exam coming up and you're nervous about it, definitely come and see us. And then, of course, at 1 o'clock, we'll also be going over self-care from the EPCC Mental Health Committee. But thank you for coming today, and I hope y'all have a wonderful weekend.